Hello, in this section we'll talk about the discrete probability distributions. And before you watch this section, um, you should check the papers and PDF for the lectures because it's very important to check different types of distributions examples mentioned in the lecture. Um, we will mention them quickly, but you need to check it on the lecture because it's important to check differences between them. So in Grec, the uniform distribution is a distribution that at each time you have same probability. So every element inside this distribution has the same probability. So for example, all of them have 3.3. All of them has 1 over 8, 1 over 10, or whatever. And that happens when they tells you that that's the same probability for everyone. The second one, which is a binomial distribution, when you have a trial. And when you do a trial like the tossing a coin and you get head and tail, and you have two things, you have trial and you have two outcomes. So for example, in the tossing coin you have head and tail. In doing experiment you have a success and failure, and so on. For Poisson, it's used when you have a rare event. So rare events will be like accident, um, telephone ring, some main street that doesn't any car pass of it, which is a rare event. The last two, the geometric distribution is for when you need to know how many times to stop before a success happens. And success here means a desired outcome. It may be in some special cases it will be a failure. So in geometric distribution it is once. So when the first time that happened, what is this probability, as we will see in the examples. The difference between that and negative binomial is that negative binomial has many tries. So I may ask about what about it will be 3 times a success, 4 times success, and so on. So first example we have at say that a telephone number is selected at random, and that suppose x is the last digit. So what's the probability that the last digit will be 6? Okay. So if you checked for this structure, so there is a numbers from 0 to 9. So we have 10 numbers to appear on the telephone number. And as it's all the same, have the same probability. There is no probability that 0 will appear more than 9, or the vice versa. So 6 will be the same as else, so it will be 1 over 10. And that's the uniform distribution. So for B, less than 3 means 0 and 1 and 2. So we'll get for everyone its probability, which is 0.1 and some. So you'll get 0.3. Here C greater than or equal, and here's the missing is 8. Greater than or equal 8. Okay. So you have two ways. Um, Here we have one way, which is greater than or equal 8. You will get the probability of 8 and the probability of 9, which is the only number that is greater than 8 that's used in the 12 numbers. So here it's 0.1 for first one, B 0.3, and C what you get for 8 and you get for 9. Second example is about a manufacturer of metal pistons, and it tells you that 12% of his pistons are rejected because it's either oversized or undersized. What is the probability that a batch of 10 pistons will contain no more than 2, which is 0 and 1, okay, and at least 2. So anything that's bigger than 0 and 1, okay. So we have first 12%, okay. So when you check this, you have a number of trials and you have a success and failure, and there is no sign of rare event, and there is no sign for trials. So you will use the binomial, okay. So for binomial, you have here n is a number of trials, and you have p is 0.12, and you have q, which is 1 minus b, is 0.8888, and 12 here is the failure, okay. So the first one, no more than 2 rejects, you have b for number of trials, and x is the number you will get. So x means the probability of 0 rejects, and you will get the 1 reject. And when you get this both, this probability and this one, you sum them up and you get the result. Okay? And we have also equal to, so we add 2. And we add those and get the result. The second asking about at least 2. So at least 2 means what? 2 or above. Okay? So for half 2 or above means you have 2 and 3 and 4 and so on. Okay? So you can collect them till 10. But there is another solution, which is when you make 1 minus x equal or less than 1. So you have 1 minus x node and x1, which we have, and get the probability direct, because it's easier. Okay? So third example is about a vehicle passes through a junction on a busy road at an average rate of 300 per hour. Find the probability that none passes in a given event. What is the expected number of passing in 2 minutes? Find the probability that this expected number actually passed through in a given 2-minute period. So at first you have big vehicle pass, and he asking about the probability of none passes. So it strikes to you that it's a rare event. So at first you need to get a lambda, okay? And lambda here will be the average rate over a period of time. So this will be lambda, okay? You'll get 5, and then you easily get the probability using the Poisson probability rule, okay? So this is Poisson. Second question is asking about the expected number of passing in 2 minutes. So we'll get the lambda times the 2 minutes, so we get 10. And third one, which is asked about the expected number actually passed through in a given 2-minute period. So we have here the expected value, or mu, is 10, and you have the probability of 10, okay, which is this value, and so you will get. So for C, he asks about the number you got. In B, find his probability. So you simply have 10, and you get the probability of 10. So you get this result. The next example is about company makes electric motors, and the probability of an electric motor is defective is 0.01. What is the probability that a sample of 300 electric motors will contain exactly 5 defective motors? So here is again talks about sample and defect. And here is asking about a rare thing, which is the defect. So we will model it as a Poisson. So we have here 300 motors. So it's again, this is the would be 0.1 times 300 would be 3. So probability of getting 5 defective is this. You'll just substitute in the rule and you'll get this probability. Number 5, here is asking about product produced by machine has a 33% defective rate. And here check the question and check the difference between this and the previous one. He asks here about what is the probability that the first defective first and here is first occurs in the fifth item unexpected. And here's the difference. He asks here about the time of event, the time of this occurring happen. And this is different for Poisson. So it will be the geometric. Okay, why is geometric here? Because he asked about the first event happen. So we have here Px5. So P first for non-defective probability, which is 0.97 bar 4 times 0.03, and we'll get the result of it. Okay. The next example is a bit little complex. So we have an oil company doing exploration inside many wells to find oil, and he tells you that has 20% of striking oil. That's 20% of finding oil. What is the probability that the first strike comes on the third well? So we have P 0.2, we have minus P 0.8, and we have R1 because about the first, and X equal 3 because we do 3 drills. So we substitute this and we get, so it's similar to the previous one. So again, he asks here about what is the probability that the third strike, comes on the seventh, and here we want it from the first to the third. So we'll switch the distribution, which is the more general, the negative binomial. So we'll substitute the rule. Simply just 7 minus 1, 3 minus 1, and here your section choose 2, 0.8 power 4 0.2 times 3, and we get the probability. So what is the mean and variance of number faults, and just substitute sort of 3 producing wells and just substitute the probabilities. Here is the mu r over p, the price is 3 tries, okay, and here's the probability, so I have 15. Here is also r number of tries times 1 minus probability, which is 0.8 times the probability squared, 0.2 squared, and we get the result.